Okay, we're now going to look at compound inequalities. So we're going to continue on where we left off, inequalities. But now we have these situations where we're going to be looking at compound or multiple scenarios, or in this case, two scenarios at the same time. And again, remember that inequalities represent situations where you have many solutions to an inequality, so keep that in mind. Now, in some cases, the solutions would be in between two numbers, or what we say to the left or right. And so we have these situations where our solution is going to be an and, where we use the term and or the term or. And so let's take a look at what we mean by that. So if you're thinking of a number larger than 5 and smaller than 9, these would be the numbers. Those numbers are in between. Right, these are the possible answers in between. And your inequality would look like that if you wrote that. So in this case, x is greater than 5 and x is less than 9. In this case, that would be the solution. Now, there's the and. I'm thinking of a number that is smaller than 7 or larger than 11. Notice that language. One's to the above and one's below, or one's to the left and one's to the right of these numbers, of the 7 and 11. And so that's what we call, these are compound inequalities when we see them, and that's how you would write it. X is less than 7 or x is greater than 11. X does not satisfy both. You have an or in those cases. So when we think about that, here's a situation where you have to solve an inequality here. So you use the same mechanisms to solve. Here we go. And so in this case, we end up with a solution here. I'm going to end up writing the answer here. You end up with a solution of -1. X is greater than -1 and less than 3. That's how we look at interval notation. This is how it looks in a graph. But again, it's the same method to solve. It's just how we're writing the answer. And then you have this situation, an or situation. You solve. So after you solve, your solution would be an or. And so these are what we talk about. So compound inequalities, but it's related to, again, what we were just solving. We just added one extra level of added a second condition, and so now we have this and or situation. And so to finish this lesson 2.5 up, we have an application problem. I'll let you take a look at that, read that, and then you can see again what's the expression that represents this. You have $45. It's $3.20 a bag. So this represents how much you would spend if you're going to do it yourself. $45 plus $3.20 a bag. And then if you wanted to determine when you choose do yourself versus hiring a professional, remember a professional costs $300. So you want to find out when this value is smaller than 300. So in this case here, you would do it yourself if, in this case, where x is less than 79.7. And again, x is the number of bags you need. So as long as you need less than that, it's cheaper to do it yourself, right? Because they're going to charge you $300. In this case, here is the scenarios where if each bag fills this many square feet, you only need 20. How many bags you need 31. And so in this case, you would do it yourself because 31 is smaller than 79.7. And then what if it only filled 0.25 square feet each bag? Then it takes you 80 bags to do it. You would hire a pro. Technically, they'll do it for cheaper since it costs more. That's it for compound inequalities.